Hi, I hope everyone is doing well. We have explored using an external EDF function in one of the previous videos, but I didn't go into details because the details were inside the function. Anyways, I read the comments on the previous video and someone notified me that there is an update in MATLAB, and this update basically they included EDF, like the capability to read EDF functions inside of MATLAB, specifically under the signal processing toolbox. So if you go to the documentation file, you will find that there is EDF info and EDF read. Okay, so let's just use EDF info first. EDF, or let's say info equals EDF info, and then the file name subject 001.edf. Notice that the file has to be in the current folder, otherwise you'll have to write or type the long form of the address of where the file is. Okay, so to make things easy like this, just make sure that the file is downloaded into, or you navigate to the current folder, okay, whatever the file is. So let's hit enter, and as you can see, these are a few details about the file. Let's double click here because I named it info, right? Created a variable in the workspace. I see that what's interesting to me right now is that I have how many signals? 21. What are those signals? Here you have signal labels. Double click and you'll see the names of the 21 signals. Alright? Okay, so keep this in mind and let's use the other function, which is EDF read. Let's say data equals EDF read, and then the name of the file subject 001.edf. Here you get the information in a timetable. So we have 21 signals here, 1, 2, 3 until 21, and each one of those signals, like the duration of recording is 182 seconds. Okay, so if you scroll down, down, up a little, down a little, here, this should be our last value. Okay, so what else do you notice here? Do you get like a regular vector? No, this is not a regular vector. Each one here, each element or each cell contains 500 values, and you can trace this back to the fact that the sampling rate was 500. Like if you go back to the source, for me, the source where I got the file, it was mentioned that there are that the sampling rate is 500 samples per second. So here, for each second, there is 500 samples. All right, and how can I use this? How can I plot, for example, EEG FP1? So to plot EEG FP1, I want to extract that as a vector. So how can I do that? Let's clear the screen and go back to this. Let's edit it a little bit. FP1 and then let's add a few things. So there is an option here to select the signal, right? Selected signals. And then if you remember from before, from info, what was the label? It was EEG space FP1, right? So I'm going to use this here. EEG space and then FP1. Okay, let's see what we get. Data FP1, you get still a timetable with the time labeled here and then a cell array here. Okay, but that's not how I cannot really plot it like that, right? So what can I do? I can say that data FP1 let's call it cell array equals table to array. That's another function. And then what was the name of the original variable here? It was data FP1. Okay, now what did we get? We removed the time labels. We no longer have a timetable. We have a cell array. What if I wanted it to be a regular array? What do I do? Let's call it here, change the name. I'm gonna edit instead of typing everything all over again. I can hit the up arrow on the keyboard and then it shows me the previous command, and I can edit the previous command. And then here I'm going to use another function called vertCat. So this is, it stands for vertical concatenation. And the previous variable was called what? Cell array, right? And then I want all of the cells. So I do something like this. So I'm doing vertical concatenation of all of the cells together. Okay, the cells that are inside data FP1 cell array. Okay, so what do we have now? Data FP1 array has basically all of the data from the 182 cells. Okay, or for the whole duration of our experiment. Now what can I do? Now finally I can use this to plot my EEG signal. So what can I do? Let's say there are many ways of doing it. One way would be to plot, and then let's just say array. Actually, it has a longer name, data FP1 array. And then as you notice, it has like a lot of values. So I just want to see the first 10 seconds, which is 500 times 10. Let's plot the first 10 seconds. What happened? Sorry, I needed to do one. Let's edit the function. I made a mistake. Here, 1, 2, from the first sample to the sample number 5000. Okay, so if MATLAB allowed 0 index, then it will be from 0 to 5000. But since we're starting from 1, then 1 to 5001, this gives you the first 5000 samples. Okay, let's see how it looks. It looks something like this. Alright, if you wanted to notice here, the x-axis is samples. I can introduce a time vector from 0 to what is the sampling rate, 1 over the sampling rate, and then I want the first 10 seconds, right? So from 0 to 10, this is my time vector. Now I'm going to use plot, but then I'll edit something here. I just added t. And now, obviously you'll have to do all the accessorizing of the figure, like type time in seconds, and then here the y-axis, label it properly. But basically this is the EEG signal from FP1, right? Another way, if you want to plot more than one of the 21 signals, let's say, let's open a new figure and then use subplot, and then 22, well, 22 is too much, let's just stick to 10. 10, 1, 1. On further information on how to use subplot, you refer to the documentation, but basically here this is allowing you to have a figure that is divided into 10 rows, 1 column, and we're putting this plot in the first position. Let's run it. Basically, this is your EEG signal for the first 10 seconds for FP1. Okay, that's it for today.